talking about limiting reactants and excess reactants. So these are going to be for the problems where it doesn't specify the other reactant is excess. Have you noticed that every single problem we've done says magnesium reacts with excess oxygen? They all say excess. If it says that, you should rejoice inside because you know which one's zero. But when it doesn't say, you got to figure it out. So, for example, let's say magnesium reacts with oxygen to produce magnesium oxide. What's the first thing you have to do? You got to balance this. If you don't balance the equation, ooh, Lord, you're about to do a whole lot of work for nothing. Okay? So, let's say that we have these pieces of information given. Maybe write these out on the side. And the reason I'm telling you to write them out on the side is because what has to go under this? The BCA table, right? So, let's say that we have the following information. We have 24.7 grams of magnesium and oxygen. Okay? And we need to determine the limited reactant. If I write LR, does that make you sad? Oh, well, you can write it out then. Excess reactant. How much excess reactant remains? And this is all grams. Mass of MgO produced. This is what we're looking for. Limited reactant, excess reactant. How much excess reactant is left? How much mass of magnesium oxide can be made? I mean, I could have written a giant paragraph, but are you hanging with me? I mean, I know you don't know how to do it, but are you clear on what I'm asking you? So, yes, ma'am.
Wait, doesn't it just tell you the mass of magnesium oxide?
No, I gave you the mass of magnesium and oxygen. So I need to know how much magnesium oxide I can make. I need to know how many s'mores I can make, but I only have that information for marshmallows and chocolate. I don't know how many I can make. I got to figure out which one I'm going to run out of first. All right, so if I have two pieces of information for grams, 24.7 grams of this and this, right? Can you go ahead and figure out moles? Like you have to, right? So go ahead and do that. Convert both of them to moles. You know how what I'm teaching you, I'm like, the people that don't do this are going to fail. You know how I do that sometimes? 100% of the time, the people that don't specify what you're talking about and the unit, you're about to solve for X, you're going to do molar conversions to get stuff to go on the table, you're going to get molar conversions to get stuff out of the table. If you don't write down what you're talking about, you're going to have a whole literal page of stuff. You won't know what any of it is. You're just going to have a bunch of naked numbers running around. That's what other chemistry teachers call it, and I think it's funny. Naked numbers. So I have to choose between getting a B on my transcript so I can go to college and writing down grams of magnesium, then I'm going to write down grams of magnesium. Anyway. That kind of got real quick, didn't it? Yeah. I'm just saying, y'all. It ain't that much work. I had a kid last period that was just writing a bunch of numbers. Like, I don't understand. And I was like, I don't either. I'm such a paper. Sorry, honey. Let's do 3 decimal places, okay? Have you successfully solved this part? Cool. Now you can actually start the problem. It's not funny. I'm sorry. Okay, it is funny. 1.016. Well, let me script. Okay. So BCA. Boop. 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 Make yourself a nice chart, right? It's the key to success is a nice chart. All right, I know this is 0. I know this is minus 2x. I know this is minus x. I know this is plus 2x. And I don't remember what I just wrote down. 1.01706. And please write down moles. Thank you so much. In my first period honors class, I did the examples and I was like, hey, everything's moles. And then I walked over to somebody's paper. They had grams and they even put a G down. No. Actually, he's really nice. Let's not call people up. 0.772. So that made me kind of sad. Can you eyeball this and tell which x is smaller?
Yeah.
Okay, if you can't, let me show you my wisdom. This is $1.01. It's about to be divided by 2. That's 50 cents. Yes. Yes, I'm in the club. Anyway, x on the second one is 70.77. So this x is smaller. If you can't do that in your head, then get to algebra in it, okay? And sometimes I can't do them in it, okay? But if you can't, then can you solve for x on both of them? The smallest x is the one that's going to be 0. So this is definitely the smallest x. Do I need to write that out to confirm it to you?
No.
Are you sure? So x is equal to, we still have to do the math because I need like the specific value of x. So to solve for x, it's going to be 1.016 divided by 2, right? Have y'all figured out that's how it goes?
Yeah.
All right, so x is 0.508. Write it down and circle it like you're in algebra, but not like in algebra. You ain't done. Once you found your x, it's not over. So what's going to be, so first of all, we have determined the limit to reactants. It's magnesium. Check. The excess reactant is oxygen. Check. How much is left though? So 0.772, and I want the mass, minus 0.508 is, oh, excuse me, ooh, oh hell, 0.620, so 0.264, wow. Been doing this all day. So that's number of moles. Does that tell me how much is left? Yes, but am I done?
No.
No. So we're going to have to convert that to grams. So I'm going to make myself a note. Go to grams. I'm not done. I'm going to do that in a second. And so the amount of magnesium oxide that can be produced, this x is the same as here. So 0.508 times 2 is 1.16, I think. Cool. And so now I need to take this to grams as well. So that's the worst part of chemistry. I don't even want to show you what that looks like without a BCA table. It's okay. I will show you how to do it. I will show you. If you really want to see like how I taught it the first 5 years of my life, I'll totally show you. But first, y'all have a little extra time. But first, if you we'll take these both to grams, please. So 0.264 moles of oxygen and 1.016 moles of magnesium oxide. I'll show you. You probably be, maybe you'll be confused. I don't know. Yeah. You good? I will do one more example because I want to make sure you get it. I want to show you something else. So 2 quick molar conversions. Your grams of oxygen should be around 8.45. Is that what you got? Okay, and then your grams of magnesium oxide 40-ish. Okay, cool. You good? You want to do another one? You want to see if you can do one? You're going to have to. I'll totally do another one, yes. Yeah, so on the test, because it's multiple choice, it might say, what is the mass of the limited what is the mass of the excess that remains, and what is the mass of whatever produced? And so it'll give you two choices with commas in between. You know what I'm saying? You have to pick the right combo. It's multiple choice. Yeah, only multiple choice. All right, let's do another example. Example number 2. So let's say that we have, I don't know, hydrochloric acid plus zinc gives me zinc chloride and hydrogen gas. So balance the equation first. Always first balance the equation. It's a tough one. Okay, I did it. Yay. Alright, so let's say that I give you 30 grams of hydrochloric acid and 82 grams of zinc. Okay, I want to know limited reactant, excess reactant, mass of ER, and then mass of H2. So I just want the mass of H2. So 30 grams of hydrochloric acid, 82 grams of zinc, limited reactant, I want that. Limited reactant, excess reactant, mass of the excess reactant remaining, and mass of hydrogen. I'm going to give you like a, I don't know, 2-minute head start. Maybe 3-minute head start. Just let me know. First things first, what do you got to do? We got to balance the equation, but then what? Go to moles. In AP Chemistry, the thing that I said every single day, is when in doubt, mole it out. We just go to moles, and then it all works out from there. On the AP Chem exam, this could be a question. This is an AP Chem type question. And so they would give you a point to go to moles, and then we'll give you another point to figure out the answer. So at least you know how to go to moles. I'm going to kind of just slowly start to fill stuff in. That sounds good. Did you get that for your moles? Is this one fairly obvious about which one of the X is the smallest? Do you need me to talk you through it? Yeah. Alright, so on zinc, I hope you can look at this and tell that X is about to be 1.254. And on this one, I hope you can tell this is 80 cents divided by 2, which would give about 0.40. So this is actually your X. So it'd be 0.41 I don't know, 1.5 or 0.1. Wait, what? 0.41. I guess it would round up. I'm a little bit tired. Whatever. So divide it by 2. Did you see I did that though? Okay. So x equals 0.41. Okay, so that's x. And I wanted the mass of hydrogen too. Has everybody gotten to this part and understand what I did? Can I help anybody? Okay, keep going and I'll stop you in a second. Okay, is this your whole chart? Is that what you got for everything? Anybody need help? Yes?
How'd you get 0.842 moles per sig?
I subtracted x.
Yeah.
Yes.
How'd you get 0.415?
I don't know. Can I tell you I've been doing this all day? It makes you dumb. Okay? I was really smarter in the first period. Better? Alright, so anyway, are we done though? No, now you have to convert to grams. But you know how to do that. Okay, so there's zinc remaining, right? Good? And then the moles of hydrogen remaining are, grams. Should have gotten 0.832 grams of hydrogen produced. Did you get that?
What?
0.832. Is
Yeah.
that what you got? And that kind of makes sense. You have a little bit less than half a mole, and a mole of hydrogen weighs 2, so can I help anybody with anything that I've done here? Y'all straight look bored like this is the easiest thing you've ever done. Can I be honest with you? This is super chill. This is it. That's all the things. Tomorrow I have a simple formula. We have to do that other lab. You want to see the old way of doing it?
Yes.
Okay. This is the hardest thing. This is the hardest thing we'll ever do. So for Christmas though, what I'd like though, okay, y'all don't understand. I'm going to help you to understand. Okay.
You are the one that's like long.
Y'all don't start fighting over there. I don't want to hear it. Thank you so much. Do you want to see? Okay, here we go. How to do it the old way. Because you may not have, like in college or whatever, you may not have them. If you don't want to listen, that's fine. Just be quiet. So the first thing I'm going to have to do is I'm going to take both masses of these and I'm going to solve for hydrogen. And some of these problems would have you solve for both masses of the products. So that really sucks. But since there's only one, I'm going to take both masses and I'm going to solve for the mass of hydrogen. The one that makes the less hydrogen will be the limiting reactant. So what that looks like is I'm going to go 30 grams of hydrochloric acid. And then I have to go, it's like the hand thing, I have to go to moles, okay? So this is 36.4463. I just happen to know the molar mass, so that helps. I'm going to legit run out of room. So this is 1 mole. And then in the balanced equation, the ratio of moles for HCl to hydrogen, there's 2 moles of HCl for every 1 mole of hydrogen. And then what you have to do now is you have to go to grams of hydrogen. So 1 mole of hydrogen is 2.02 grams of hydrogen. So all that looks familiar. So I have to do all of that work. And then I have to do that same process again, starting with the 82 grams of zinc. And then what I'll do is, that one will be the limiting reactant. And then once I figured that out, then I'll have to do another conversion, taking it to grams of the limiting reactant, and then I'll have to subtract. But see, the thing about it is, if you're not super good at this, you don't know where you are, and it doesn't tell you where to subtract when you don't know. But you basically do this 4 times, and then you have random numbers, and then you have to, in your mind, without any guidance, figure out what to do with them. So, sounds terrible, right? I can show you one in the book, but I'm done. So you're going to make yourself have homework if you don't get busy. The number 1 and 2, you know there's like a thing on the back? You know what I'm talking about? Try number 1 and 2.